Well, thank you for joining us on exercise 3G. I'm going to be looking at question 4B. And this says to find the complex number z that satisfies the following equation. And this has a z minus 2 on the numerator, a 1 minus 2i on the denominator. The right-hand expression is z minus 1 and 2 plus I. Well, let's cross multiply, see what happens. We could rationalize the denominators, but I'm just going to cross multiply, get rid of denominators. So that would be z minus 2, 2 plus I equals z minus 1, 1 minus 2i. So let's expand here. So we've got z times 2, z times I, negative 2 times 2, negative 2 times I. Oh, that's the left-hand side. Now z times 1, z times negative 2i, so negative 2zi. Negative 1 times 1, which is negative 1. Finally, negative 1 times negative 2i, positive 2i. Is that a 1? Yeah, let's just check. No. I just noticed that z minus I wrote z minus 1. Can I fix that now? Z minus I. Let's just double check all the others. It's my i's. So z minus I, I'm going to change that to z minus I. And that changes, doesn't change z time doesn't change that one. Negative 1i. That changes this to negative 1i. I'll put a negative I there. And this changes this to negative positive 2i squared. All right, so hopefully I fixed up that mistake. Okay, let's continue. And where are we up to? So let's take the I squareds and make it negative 1, because I squared is negative 1. And over on the right-hand side, we've got a 2i squared. That becomes 2 times negative 1. So we'll change that to negative 2. I will bring the z's to the left and take the numbers with terms without a z to the right. How about that? So we'll leave the 2z on the left. We'll leave the zi on the left. We'll take that negative 4 over to the other side to become a positive 4. And we'll take that negative 2i over the other side to become a positive 2i. We'll bring this z across to the left to become a minus z. We'll bring this negative 2zi across the other side to become plus 2zi. And we've already got a negative I on the right. And I was going to change that plus 2i squared into minus 2. Okay, so let's do that. Good. So let's factorize the z on the left. And we've got 2 plus I minus 1 plus 2i. And bring the real components together. Oh, did I make a mistake over here? No, that's fine. Let's keep going. No mistakes. Negative 2 plus 4 becomes 2. And minus I plus 2i becomes 1i. All right, good. Let's see what this bracket becomes, and we've got 2 minus 1 is 1. I plus 2i is 3i. And now we can take that bracket across. My pen's misbehaving. 2 plus I. I might need to get myself a new I pen. 1 plus 3i. I haven't experienced this before with the pen not working. Now, when it's multiplied by the conjugate of 1 plus 3i, and if it's a 1 plus 3i, we'll make that 1 minus 3i. 1 minus 3i on the denominator, 1 minus 3i on the numerator. And let's see what we get. So 2 times 1 is 2. Two times negative 3i is negative 6i. I times 1 is I. And I times negative 3i is negative 3i squared. And our denominator would be, I've just done a whole lot of expanding, but we've got a plus b, a minus b. You might recall the rule a plus b, a minus b as the difference of 2 squared, which is a squared minus b squared. So let's just apply that rule rather than expanding out using the green loops. So I'm just going to now go 1 squared is 1 minus 3i squared is 9i squared. 3i times 3i is 9i squared. Now I squared, which we mentioned was negative 1, therefore negative 9i squared is negative 9 times negative 1, which is 9. So let's replace that with 9 on the denominator. And 3i squared, we've got a minus 3i squared over there. So that's negative 3 times negative 1, which is positive 3. So let's change that into 2. Minus 6i plus I is minus 5i. And replace that with plus 3. And replace the negative 9i squared with positive 9. So we've got 10 on the denominator. 2 plus 3 is 5 minus 5i over 10. So we've got 5 over 10, which is a half, minus 5 over 10, half I. And there we have our Z. I hope this has helped. Until next time, stay happy.